Presentation's entitled Getting Energy Efficiency Right. It's come about through some work we've done with the Department of Environment and the Victorian Building Authority around their energy efficiency program they completed not so long ago. Sorry, just before we start, I just want to acknowledge the traditional custodians of country throughout Australia. We pay our respects to elders past and present, and we embrace our shared future. So tonight we're going to go through the expectations according to the NCC 2019 and the relevant Australian standards. Now they came into effect at the beginning of this month, at the beginning of May. So that all applies now for all new constructions as well. So we'll go through those. We'll go through the details of the Department of Environment, Land, Water and Planning and the VBA Energy Efficiency Program. We'll look at what they found, some of the common issues they identified about through the program about energy efficiency compliance on building sites, and then we'll look at the methods to improve energy efficiency outcomes. We'll have a short break about halfway through as well, just to get you standing up and moving around a little bit, because it does go for a little while. So let's keep going. So why is all this important? I guess we want to start, we want to be building better houses. We want to make sure that we comply for a start, but we also want to make sure that we're doing the right thing by our clients, and that their house is healthier and more comfortable to live in, that it's not freezing cold in the wintertime and boiling hot in the summertime. And there's really good evidence now that suggests that not only does cold have a negative impact on people's health, but also heat. And we see things like increases on emergency services during major heat waves, as well as when it's really cold. So it's really important that we provide houses that people can live in and live reasonably comfortably in. Also, the other important thing, and probably something you're noting at the moment as well, is that we want to get as much natural light into these buildings as possible to make sure that we provide the best conditions in terms of positive mental health. It's acknowledged that natural light has a big impact on people's mental health. So trying to make sure that that we get enough of that as we can is really important as well. And of course, it's important to the impact on the environment. The greenhouse effect is here, it's real. We can look at the sort of information there we're starting to see now, where those top 10 years, the top 10 warmest years ever recorded, and since about the 1860s in Australia and the 1880s and most of the world, have occurred in the last 15 years or so. And I sort of link that to, I have a daughter who's 15 years old, and 10 of the hottest years ever recorded have happened in her lifetime. So 10 of those 15 years have been hottest events. And that's quite significant. We've seen, in fact, I think it's the last 4 or 5 there that have occurred in the last 5 years. So, that's significant change there that we're starting to see a strong pattern, and it's early days yet. That's the scary kind of thing. So certainly that has an impact, and that's important. Okay, so for the building code, we have a number of ways of complying with the energy efficiency requirements. One is using the NatHERS rating, or the star rating system, and the modelling, the computer modelling. I'll talk a little bit about what that is in a little while. And then there are performance requirements. Now I know this is one of the questions we got, so we'll look at this a bit later. But so it's either a performance requirement or a combination of both. So it can be deemed to satisfy via the prescriptive NCC requirements, and that's that kind of cookbook approach. The walls are this side, the windows need to be this size, those sorts of things there. Or a performance solution where a consultant is engaged to provide an alternative solution which says that, look, what this builder is doing is the same as meeting the requirements in the building code. It's just a different way of doing it. But the problem with that is that it has an expense connected to it. So, that's the issue there in terms of performance requirements. So the more we can simplify this and reduce the need for performance solutions, the better we are in that sort of sense as well. And sometimes that's, strange designs and those sorts of things that we can't really get around. Sometimes it's things that, are fairly simple to fix in terms of adjusting the building code or adjusting the requirements. So what's in the star? So the NatHERS rating is the energy rating, we sometimes call it, is basically a computer simulation that estimates energy use. So, you know, things like the orientation of the building, where north is, where south is, where the windows are, what types of windows are in there, how much insulation is in there, is there any ventilation there, natural ventilation, how much thermal mass is in the building, has an impact on how much energy that house is going to use, or that apartment's going to use. So with all those factors considered, the computer simulation spits out an answer which says that in summer it'll use this much heating, require this much heating or cooling, and in winter it'll require this much heating or cooling per square metre of the size of the house. Currently, the star rating is 6-star for residential. You know, we were hearing rumours about a push to 7, but you know, I'm not sure where that's going to head. Given what's going on. But we'll certainly see there is a strong push to increase that over the next few years, and there is a trajectory for zero carbon housing in the next few years as well. So you know, we'll see those sorts of things come into play. So I want to just play the NatHERS video here, which just sort of explains that a little bit as well. So.
Many of the things we buy are classified with star ratings. They can help us choose a hotel, a movie, even a fridge. Even with the most expensive things we buy, our homes, there's also a star rating. The Nationwide House Energy Rating Scheme, or NatHERS for short. NatHERS uses software based on scientific research by the CSIRO and has been refined over many years. The software models your house plans to estimate the amount of energy it will need for heating and cooling. Taking into account hundreds of factors, such as the building's construction, local climate and orientation, our National Star Rating System scores your house between 0 and 10 stars. Builders often use a NatHERS rating to show a new home or renovation meets the minimum energy efficiency requirements in your state or territory. But if you want more than the minimum, it's best to get a NatHERS assessment at the planning and design stage. This is when a NatHERS assessor can give you expert advice on how to build or change your home to improve its energy use. Take this house for example. Through careful design, it has been made more comfortable to live in and requires less energy to heat and cool. Its kitchen, lounge and living areas are on the north side of the house. Its windows, eaves and awnings let sunlight in or block it out at different times of year, which helps keep the inside temperature comfortable throughout the seasons. Insulation, well-placed ventilation and careful material choices also help to keep the temperature right. All these design choices increase this home's NatHERS rating and make it more energy efficient, perhaps at no extra cost. Remember, the more stars your home has, the more you can potentially save on energy bills, the higher its resale value could be. And of course, by reducing your energy needs, you're also helping the environment too. Just search NatHERS to get started. NatHERS, ratings you can feel comfortable with. For more.
Okay. So look, there's quite a bit of work that goes into that model, and it's updated and tweaked every once in a while. We know it's not perfect. There are some sort of funny results sometimes in it. You know, people who like rammed earth and mud brick houses have been complaining about it for years, but it works pretty well generally to give an indication of that. And just the other point I want to make too is 6 stars is the minimum rating. So it doesn't necessarily mean it's fabulous. It's the minimum current requirement. And you can see there, the picture there is one by one of our builders, Jeremy Spencer, Positive Footprints, and he's got that rating of that house up to 8.6 stars there. You know, north the front of a block. So it's interesting because it's not actually the perfect block to get a big star rating on, but he's managed to do it in a variety of different ways there. So you know, certainly that's possible, and that's important to remember there as well. So it's worth sometimes talking to the energy rater, the builder, just to sort of go, look, you know, what would it take to get it up to 7-star or what have you? Because some designs, it's not that difficult to do. Okay, so the updates to the National Construction Code, which came out last year, and as I said, the transition periods ended at the April 30th, so they come into play now. And what they did was separate heating and cooling loads in those in that rating, and that was because we were starting to see some funny things happen. You know, for example, I was starting to look at, you know, houses that had 8-star ratings, but it had no shading on the north side of the house during summertime. So those houses would have been quite hot during summertime. So what they've done is separate the heating and cooling load limits and said, right, there are now minimum requirements that we need to meet for winter and we need to meet for summer as well. There are condensation requirements in the code now. So we introduced the idea of a vapor permeable membrane for climate zone 6, 7 and 8. And what that is described in the Australian standard there, listed there. And there's a little snippet out of the Australian standard there as well. But basically it's a sort of membrane that allows moisture that's in the air. So I guess like humidity, if you like, if we sort of talk about it like that, to get out of the house, but stops moisture in a liquid form from getting in. The little molecules in the moisture in the air are further apart, so they can get through the membrane, but liquid molecules cling together and are bigger, and so they can't get back in. A bit like Gore-Tex, if you like. So, you know, if you wear a good Gore-Tex jacket will let the sweat out from your body, but won't let the rain get in, won't let the moisture get in and wet you. So it's a bit like that. So we've seen that requirement in there. So making sure that you are fitting the right sort of membrane is really important now. There are changes to the external discharge of exhaust systems as well. You can still vent them into the roof space, but it's quite difficult and you need to provide quite a bit of ventilation in the roof space to make sure that moisture is not collecting in the roof space. But most of those exhaust systems now will be ducted and will be either straight out into the outside air as well. Yeah, and as I said, the ventilation requirements for the roof space have also changed. There are building ceiling requirements as well. So there's now an understanding that, sorry, I'm just looking at two screens here, so I'm sort of between. So there's now an understanding that the air leakage rate should be no more than about 10 cubic metres per hour per square metre. So what does that mean? Basically, it means that it can be measured. Normally, it's a part of deemed to satisfy requirements of the house, but there is a provision in there now to show that you've met the performance requirement by having a blower door test done. And that's that picture in the bottom there. And basically, what they do is they stick a big fan on one of the doors. They seal off everything in the house. They close off everything in the house, make sure all the windows and doors are shut, and they suck the air out of the house. They put the air under pressure to simulate, what would happen when the wind blows on the outside of the house at about 30 kilometres an hour. So 30 kilometre an hour wind, when you're looking at a tree, the small twigs are starting to move and the leaves are moving. So, you know, fairly stiff breeze, but not a gale. And they sort of saying that there should be no more than 10 cubic metres of air change per hour. And, you know, 10 cubic metres of air change per hour, I've had it explained to me, it's like having a hole the size of a $2 coin every square metre in your house, pretty much, on every surface of your house. So it's not extremely tight, and we'll have a look at a bit more about that later on as well. There are deemed to satisfy requirements, so that the roof lights or the ceiling lights should be sealed. So the old gimbal downlights, for example, don't comply anymore. There should be ceilings around, ceiling around doors and windows, and they should be there and in place. When that building wrap is put on, it should be taped to the sides of the windows there to make sure that it's fairly airtight as well. Okay, so the details of the VBA program. So during 2018 and 19, Department of Environment, Land, Water and Planning, in partnership with the Victorian Building Authority, went out and ordered a whole bunch of building sites. There are about and what they wanted to do was to see how they effectively complied on site during construction with the National Construction Code and relevant Australian standards. So they did about 2,000 inspections up to about December 2019. They were going to complete a few more this year, and there's a major report out due, I think, in September as well. So we'll get the full details of that then. But what they found, they did them on a bunch of housing sites. So what they found was there was a couple sort of consistent things that weren't up to scratch, if you like. They don't call them non-compliance, but they, certainly call them areas for improvement. So that was things like the paperwork sometimes didn't match what was happening on site. So, design changes, if any changes are made to a building, they should be noted. They should be noted on the plans, and the building inspector, but the building surveyor, should be notified as well of those changes. We'll talk a little bit about that as we go. They found that there was product substitution, whether it was you know, deliberate or not, but sometimes there was incorrect R value of insulation fitted, so it didn't match what was in the design. The windows sometimes didn't match. The sizes maybe were different, their location were different, the type of window was different than was stated in the design. They found issues of poor quality installation as well. So things like, you know, insulation not installed correctly, and we go over this. I go over this all the time. You know, making sure that it's installed correct. There's no gaps in it. It shouldn't be compressed to fit. It should form a real barrier for that building. There were missing dampers from things like exhaust fans. So that, again, they were not compliant, and they were missing door and window seals as well. So, you know, some of the things, if there are variations to installed plans, then, you know, if the product is not as specified or the design changes, things like different windows. And again, like I said, you know, the type of windows change, whether it be aluminium or timber, or, you know, the type of glass changes, those sorts of issues as well. The window may be moved, and that changes its orientation, which has an impact on the NatHERS rating. If the insulation changes, that has an impact on the NatHERS rating. So that's why it's really important to let people know that these changes are happening. Sometimes you think they're not that big, but they certainly still need to be identified as well. So, and the same sort of information that we put out to builders constantly as well. If you're making a variation, so any changes to design or material specified needs to be noted to noted as a variation to the contract. We need to note it on the plans. We need to advise the client in writing of those changes, and the building surveyor needs to be notified as well. So, and they'll decide whether it's a major change that might require that the energy rating is reassessed or not, but that's up to the building surveyor. So these changes need to be noted, and people need to be told. So look, just the other important thing is to make sure that the NatHERS certificate is an official certificate. How do we know that? On the right-hand side of the certificate, you'll have the branding there, the NatHERS branding, and the star rating will be listed there. As well as that, there's the Q code in the bottom right-hand corner there. Geez, my brain's barely working this afternoon anyway. And if you scan the QR code, it will take you to the First Rate 5 website, and will show you that, you know, whether it corresponds to the house address that you've actually got modelled there as well. So it gives you a bit of information about that. It tells you that it was completed by an accredited NatHERS assessor as well. And the NatHERS assessors are audited, and there are all sorts of quality assurance in what they do. So it's important to make sure that you're getting an official one of those as well. It is really important. The other thing to do is to check. To match the inputs, match the plans and the specifications. So you can see part of the certificate, on another page of the certificate, it sort of lists, you know, the sorts of windows that were inputted into the model, the amount of insulation, all those sorts of things there. So, you know, maybe you want to check a few of those, cross-check a few of those to make sure that it actually matches the plans as well, which is really important. Okay, so just to summarise where we're at the moment, yeah, so just making sure to check that what happens on site matches the drawings, the NatHERS certificates and the contract. It's really important. That the products are correct, that you are receiving what was ordered, and they're installed as specified is really important. If a product is substituted, make sure the changes are noted and are approved by the building surveyor, and the impact on the star rating is checked as well. And that's really important. So I'll just finish off this section with a short video from Tony Bagia, our technical advisor at Master Builders. Is just going to talk about how he views this as a you know, building surveyor point of view, and through a regulatory point of view, and then we'll have a look at some of those questions. Let's get this going.
Might seem a really simple little process, but it does require a number of steps that need to be considered and administered through to make sure everything's done above board. First and foremost, it had to be the discussion between the consumer and the builder. make sure that they're both on the same page. So they'd have to enter into contract variations. And then also have to be amended architectural plans. And if it's been moved significantly, then you would have to get amended structural drawings as well. You would need amended energy report. This could also lead to requiring amended planning permits, developer's approval, and then as part of all that process, the finalised part would be to actually get the building permit changed, because the building permit would be made up of all those documents. And the energy rating, like if you're moving one window from, as you know, Phil, if you're moving it from one side of the building to the other side, you might have a lounge room that's on a corner of a building, and it could be, one could be west facing, one could be, say, north facing. That you're going to have significant impacts in that space. But it's not just energy; it also could impact things like overlooking as well. Look, I think the end game is, I think really good planning in this space is vital. I think we're all quite aware that things do change on site, but we've also got to be mindful that there are responsibilities for practitioners to make sure that they abide by the Act. And I'm not stepping on a soapbox to emphasise this, but I think it's important that everyone is aware of it, that it is an offence to do building work contrary to approved building permit documents. So if there is a change, have the conversation, work out what you want to do, follow the right steps, and protect yourself from any sort of disciplinary action from breaching those requirements.
All right, thanks, Tony, for that. Okay, let's. All right, so look, before we go on to that activity, let's have a look at some of those questions there and see how we can go. Paul, how does minimum star requirements apply to renovations, especially if limited capacity to change insulation within existing buildings, walls, floors and roofs? Yeah, this is the one I have fun with all the time. And we've got there's a table that exists. If you go to the VBA website, you should be able to download a copy of the practice note for energy efficiency requirements, and that lists the changes required during renovations. So, for example, I think if it's less than 25%, then the space doesn't need to comply. If it's between 25 and 50%, then the new part of the building needs to comply. And the old part of the building is up to the building surveyor's discretion. So, for example, if you're doing a decent sized renovation in a building and there's no insulation on the roof, the building surveyor will say, look, make sure you insulate the roof while you're at it. While you're putting it in the new section, you might as well do the rest of the house. If you're pulling off plasterboard in the old part of the house, they may say, look, put insulation in the walls. So, yeah, and above 50% floor area, I think the whole of the house has to comply with the energy efficiency requirements. But again, it's up to the building surveyor's discretion. So, if it's an old Victorian house, tiny windows, it's still going to struggle, but they may say, look, you've done what you can, that's fine. So look, have a look at that. Yeah, that practice note, that'll give you a bit more information about that. Susanna, energy efficient doors about double the cost of normal aluminium. It could muck up the whole payment schedule. You're probably right. I think when it comes to getting really good quality doors, they certainly make a difference to the cost. So, that's a design thing. That's a thing that's going to impact on, big concertina doors, those sorts of things. Yeah, absolutely. So, again, it's all of this is a variation to be agreed between you and the client. Hopefully that sort of thing would have been picked up right at the beginning as well. So, that's the sort of discussion that you probably should be having with your client before everything begins and the final contract is signed. Yes, we can put in these doors, but this is the issue. If you put these doors in, we can put these doors in that are better, but of course it comes at this cost, added cost. So what would you like to do? But and at the end of the day, it's the client's discretion. But I think it's a good conversation to have with people to inform them. And as a professional, and as a client on many occasions, that's what I appreciate. That these are the options there, and this would be better if you did it like this, Phil. But of course, at the end of the day, whatever you do, that's up to you. as well. So yeah, look, the renovation does apply to, the legislation does apply to renovations. Thanks, Sal, good to see you. And I think Tony there just put some information on the chat space there about where to get that information about the renovations as well. So yeah, if you're doing renovations, it's important, you know, some of the things will still apply to the new part of the renovation requirements as well. So yeah. Yep, thanks. Yep, thanks, Tony. That's on there. Okay, yeah, so thanks, Paul. That's another really good question. Passive house achieves star rating net zero. How does NatHERS consider this? This is one of the joys of the NatHERS rating. The passive house actually scores reasonably average in the NatHERS. So a good passive house will get maybe 8 stars, maybe usually about 7, but maybe 8. But we know that they are much more efficient than that, and in fact, 0 carbon. So yes, that's the downfall of using the NatHERS system in that sort of sense. And I get that all the time from builders. Absolutely. So, you know, passive house is really important. We'll talk a little bit about that later as well. The DTS provision seems to be easier to comply with, then why would we need a star rating? Look, sometimes it's easier to get a NatHERS assessment done than to do the DTS. Sometimes if the plans aren't, you know, depending on the design, it can be quite complicated. So it's easier to run it through a NatHERS rating. The bonus of the NatHERS rating is that it may give you options to improve the rating if you like. You know, they might run it through the plans and it say, look, John, you're getting 6.5. If you do, you know, if you up the insulation a little bit here, spend a couple of $100 on insulation, you can market this house as a 7 or above, or, you know, in terms of doing it for your client as well. So, you know, that's the benefit there, if you like. And like I said, for some people like it because it's just easier. They just, you know, run the plans and they get the information. Okay. How are we going there? All right, good. Good, all really good questions. A little bit more difficult answering in this sort of environment. Sometimes it's nice to throw these around the room, but I'm sure there are people who are putting in, you know, comments and that sort of thing as well. So happy for you, you know, if you've got some answers to these questions yourselves, you know, happy for, you know, it'd be great if you could share that sort of information as well. Okay, is passive house going to be an alternative to NCC in 2022? I haven't heard this, and you're right, you know, it would be a good idea as Green Star is in volume 1. I think the issue is that we've got to slip passive house into our regulations because currently it kind of sits outside of that and we don't know how to deal with it, pretty frankly. So that's the reason it's sort of working outside the regulations at the moment. But it would be a good thing. By 2022, not sure. But you're right, if someone scored passive house, then they shouldn't have to do an NatHERS rating or anything like that. You know, pretty much they've done well exceeded those minimum requirements. So yeah, and look, you know, it's an interesting thing. I think it's interesting with passive house because when I first learnt about it, I thought it was a fantastic idea. But I didn't think I'd see so much of it in Australia. But we're starting to see a quite, you know, significant number of passive houses. I just about hear about a new one every week or so. So it's quite interesting how many we're getting. So we'll see that becoming really good. And like you said, if someone's going to the trouble to do that, like the Green Star rating, you know, there should be some way of streamlining the whole process to reward them for that. Yep, yeah. It's interesting. Okay, that's interesting. The glazing calculator associated with doing a DTS it makes it very hard to find a compliant, affordable window. That, you know, look, that's interesting. I hear that sometimes, but you know, like I hear lots of examples from builders who are able to find really good quality windows that aren't that expensive. You know, so certainly keep an eye out for them, keep a lookout for them. We try and encourage some of these companies that are doing that. Sometimes they're importing them, unfortunately, but certainly there's some, you know, good quality windows out there that shouldn't be that expensive to do. But you know, we'll talk a little bit about that later on. Okay, I might just quickly go back to the presentation. So let's do this. So back to that. Yep. Okay. So can you see the presentation again? No.
Yep, we can.
You can. All right. Okay, cool. It's working for me as well. That's always good. All right, thanks, Victoria. So yeah, look, just look, one of the things, how we going? 440, okay, yeah. One of the things I wanted to get you thinking about is, and it's probably a good thing to do if you're building or involved in this sort of thing, is to have a quality assurance checklist in the way. You know, it's something we've played around with putting together for a while. The idea is that, you know, at various points of the building process, you want to check for these things to make sure they've been done correctly and that they're in place. It's one way of, like I said, reminding yourself that you need that, you know, just to check and make sure it's done. The other thing is that it's a really useful sort of thing that you can have that you can hand over at handover. And it shows that you're paying a little bit more attention to what you're doing and that you've done, you know, what you can to make sure that everything's right. So, you know, so for example, think about, you know, where in the building. So probably, yeah. So think about, you know, where in the building process you would check these things and then give yourself a trigger to make sure you've done it. So, you know, were the windows the correct ones? Were the seals in place on them, windows and doors? Were dampers fitted to the exhaust fans correctly? Were the insulation values correct? Was the correct glass and windows provided? You know, so correct specification of those. So it probably would look something like this, you know, which building stage windows are specified. So maybe, and then, you know, some comments, yes, correct, check, and then you've got that for the end of the project, like I said. Probably a good little thing to have. So look, before the break, we talked about, you know, those areas that are important. So the idea now and the non-compliance issues or the areas that for improvement. I just want to, you know, start looking at a few tips and things about what we can do around these areas now. So, you know, windows are important. Where we put them has an impact on again, the energy rating of the house and how much energy is needed to run the house. And also natural light inside the house. So, you know, we put them on the north side as much as we can. We'll get that sun in. We can put eaves or shading so that we can get the sun in the winter, but keep it out in the summertime. We could shade those east and west facing windows as well. Different sorts of shading systems, you know, sort of batten systems with gaps. So again, they'll let the sun in when it's at a certain angle, but they'll shade that window when it's, you know, higher in the sky in the sun as well, and different shading devices there as well. So there's, you know, there's a bit of information about showing the sorts of rules of thumb in terms of what's going on there. The properties of glass are important, you know, so what we talk about with glass is one thing we talk about is solar heat gain coefficient, and that's the ability to either let heat from the sun, direct heat from the sun in or out of the, into the building. So standard clear piece of glass has a solar heat gain coefficient of 0.77, and if we treat it with a low E glass, then that solar heat gain coefficient is lower. So this can have a positive and negative thing if we think about that. You know, I guess if we're building the house correctly and we've designed it correctly, we want to get the maximum amount, or in Melbourne, in a cold, you know, colder environments, we want to get the maximum amount of sun into the house and through, and the solar heat gain. So we want that solar heat gain to come in to land, hopefully on a thermal mass, you know, high thermal mass area, a concrete floor or a brick area or something like that, and that will warm up those areas and will keep that house warm during, you know, as the temperature inside and outside starts to cool down. So, you know, so yes, we would want the maximum solar heat gain coefficient on the north side to get that heat from the sun in the winter time. And of course, we need to shade it then in the summertime. If we've got west facing windows, so that they're going to be likely to be heated up at the end of the day as the sun's lower in the sky. So they're difficult to shade. So we may start thinking about what can we do to that glass that we can reduce the amount of heat coming through the glass in that sort of sense. So it's there that we would look at tinting and that sort of thing. But, you know, that depends on a whole lot of other factors as well. Do you like tinted? You know, when it's going to affect the colour of the light inside the rooms. If you've got a view, it's going to affect your view. All those sorts of things as well, of course, need to be considered. You know, not that easy. The U value of the window means the ability to transfer heat and cold directly through the window, or, you know, excuse me. So that's things, you know, that's the, you know, the idea that the outside temperature stays outside and doesn't travel through the window and doesn't get conducted through the glass and into the house. And that's really important. And that's really difficult to do with a single pane piece of glass. So you can see there an aluminium window, which is a really good conductor of heat or cold. That single glaze with 3mm sealed glass has a U value of 6.9. So pretty high compared to a timber window, which is not a conductor, or a UPVC window, which again is not a conductor. Fitted with a reasonably good double glazed unit has a U value of half of that as well. So that's going to impact on the thermal comfort inside the house, or how much that house heats up or cools down. They're the sorts of things in terms of the window. So making sure that what's delivered is correct, that the right glass unit is fitted in that window is correct, and that if any of that glass is treated, that that's correct as well. Seals, again, just making sure that they're installed, that they haven't fallen out, excuse me, in construction. During transport, making sure they're all there. We're starting to test now windows in terms of their ability to see how airtight they are, so they should shut firmly. You should hear them, that seal really lock into place. The window shouldn't rattle, all those sorts of things. It shouldn't flex. And that's really important. I've got a clip here I did an interview with a person from Pat from Rylock Windows, who talks a little bit about this sort of importance. So we're here today with Pat McLeod from Rylock Windows and Doors, and we're going to talk with Pat a little bit about the important role of windows in housing construction and making sure that we're getting the energy efficiency right and complying. So the important features of windows. So Pat, can you tell us a little bit, you've been with Rylock for a little while, and with windows for a while. Can you tell us about the importance of windows in the house? What's their sort of function, if you like?
Well, really, the window itself or door, its main function is really to bring the inside out, outside in.
Everyone who wants that.
Exactly right. Yeah. Everyone wants the indoor-outdoor feel, but we also have to control the environment. So we want to keep our heat in winter, and also reduce the summer load into the house. So the
placement of the window in the house is important, obviously, because we want to get it where we can get that sun in the winter.
Correct.
So keep the sun out in summertime when it gets hot.
That's right. Yeah. So good design for that.
Good design is the first principle, and then also making sure that once the house has been constructed, that we're actually fitting what was specified, because that's important.
Absolutely. Well, these days with compliance and particularly energy reports, which is a main part of what we do, we have to make sure that we're complying to those reports.
Yeah, because if we change the window, then we're affecting the energy report.
Correct.
If you like. We're changing the result of that energy report.
That's right.
So when I'm looking at a window, what am I looking at as the important features of the window?
The window is fit for purpose.
Okay.
We don't want it to fall apart in a couple of years. Sure. We want to make sure the hinges and all the points holding it together are still going to be structural in a couple of years.
And that's important too, I guess. We don't want the windows to become rattly, if you like. And rattly is a bad indicator of air tightness, isn't it? If the window's rattling, it means it's not fitting tight.
Absolutely.
And so we're getting air leakage.
That's right. Sealing is equally as important. Doesn't matter how good the window rates from an energy point of view or the glass point of view. If it's leaky, it's not going to service its needs. So a double seal everywhere. There's perimeter seal on both sides of our awning sash, which gives you that suitability and also for negative and positive pressure.
And you've got these connections on the side here, these extra connections.
Correct. Most people just start with, or most manufacturers just start with the awning sash, but under negative pressure, you can see there's a lot of movement there, particularly from when an air conditioner on or as a heater is on, pushing that air pressure out of the building. Some simple latches can stop that. Again, that comes down to, it doesn't matter how good your window rates on paper, it has to perform in the real world.
And of course, so we've spoken about the hardware, if you like, of the window. The other important features, like the glass is important.
That's right. All our products are designed to be either single glazed or double glazed. What you're seeing here is a double glazed window unit, and that will generally start with 2 pieces of 4mm toughened glass and an airspace in there, generally a 12mm airspace.
12, yeah.
Argon gas is a standard product for us as well.
Yeah, and some people started looking at the benefit of using low E glass or the E-type glass. What are we talking about there?
Okay, so low E is a metallised coating on one of the panels of glazing. That can come in either a single glazed or a double glazed form. In the double glazed form, the low E coating is on the inside of the double glazed panel, so there's no maintenance issues associated with that. What that does, really, it keeps more energy inside the house. So it's more designed for a winter purpose. We are a winter climate. It costs us more to heat a house than it does to cook a house in Victoria. So what that will do is really it's a reflector, or it will bounce or keep the winter energy in your house longer.
So that's important too. So if those if the plans have specified low E glass, I've got to make sure that when that window arrives on site, that's what I'm getting.
Absolutely. Because
is there a way I can check that? Can I kind of see that in the glass?
Look, it is hard to tell. There are some very high performance low E products out there. It is really hard to tell. So it's making sure that you as the consumer, making sure the window fabricator is putting in what is.
And I guess that's a good thing too, because we don't want that coating to impact on the kind of light we're getting in the house, are we?
Absolutely. So there are other products. There's tonal glass products which can actually work against your energy rating. So putting a grey or a heavy tint on your glazing can actually stop your winter sun coming in, which impacts on your overall thermal performance of your property.
So they have their place, obviously. So we're putting them on the west side of the house, trying to keep that hot summer sun out.
Yes.
But on the northern side of the house, we want to get that light in.
That's right.
And also, I guess we want to be able to look out and not, looking through a grey glass or something like that. We want that view to be as clear as possible.
A tinted glass, although great for summer, particularly on that west side, it's going to create a dark room in winter. And nobody wants that. No one wants to be flicking lights on in the middle of the day, consuming more energy.
That's right.
Because of what we've done. From maybe a bad glass choice in the initial stages that we purchased.
So it's working against us, if you like, and we don't want to do that.
Yep.
So Pat, before we spoke about the importance of getting a good seal, can you show us on this unit what you mean by that?
Sure. So this is the Architectural Series sliding window. I'll open this up for you. You may hear the seal moving there. So all our products have a double perimeter seal on both sides of the sash. There's a full perimeter seal with a wool pile, and it's also got two thin pieces of plastic in there which creates a flange up against the side of the sash. So when your window is closed, you're getting a full perimeter seal for your negative and positive pressure all the way around, and that's to reduce your air leakage.
So when the wind's blowing outside, it's not coming in?
Yes, southerly winds will act like a magnet on our house. They'll actually draw heat out of our house. So we want to stop that happening, and one way to do that is through the seals.
Pat, if you can we're looking at a door now. Can you explain to us, the features of this door in particular?
Sure. So similar to the sliding window, the seals in this product, again, a full perimeter seal both sides of the door panel. So when the door is fully closed, you've got that seal on both sides for that positive and negative pressure. Again, we have the wool pile with the flange inserted into that, which creates a nice seal up against the door. And when we're using a pair of doors coming together, we actually use 4 seals in the side here. So when that fully closes up, there's fully 4 seals through the length of that component.
So again, you can see when the door comes together, it's nice and tight, there's no movement.
Yes, absolutely. Phil, really a real life example today in regards to glass is a lot of customers, particularly the end user, want to use a grey or a very heavy tonal glass for their front facade. And that's all about aesthetics to them. But the problem with using a heavy tint on their product is that it's not going to comply to the energy report, particularly if their front facade was a south or an east side. We want to be able to harness that winter sun, and this is actually going to work against them from their energy report. So unfortunately, sometimes what the customer wants or thinks is a need, we can't use in their project.
So that's important then during your construction process, if the customer's coming to you as a builder and saying, oh, we saw this house on the weekend and it had grey looking glass, which we thought was really nice, can we get that?
Yeah.
They've got to go back and make sure they check that against their energy rating to make sure that they still comply.
Correct, and in most circumstances they'd need to rework their energy rating completely to get that into the project.
Because the colour's going to affect the amount of warmth from the sun that comes into the house.
Absolutely, yes.
So Pat, we've got a couple of examples of low E glass here in front of us. Can you talk us through the different types and how they're used?
Sure. So we've got three double glazed panels here. We've got a piece of clear glass. So two panels sandwiched together, both in clear glass. This is a low E glass, which has a very fine metallised coating on it, which is designed again to keep that winter heat in the house. And then we have a tonal glass or a grey, which again is double glazed, and we can certainly see there how the tonal glass will stop that summer sun coming into the house, but also stopping that winter sun coming into the house, which we really want to harness.
Yeah, so almost the colour, changing the colour of the glass to reduce the amount of sun coming in is almost the last resort, really.
Correct.
We should be designing that out of the house, if you
Absolutely.
like.
Yes.
Yeah, and I can see here that the low E glass, you know, it's very similar. There's almost imperceptible difference between the two.
Very hard to tell the difference between the two. Hence, that's why clear low E products are very good for our environment, because we can get that extra winter efficiency, but not lose sunlight, winter sunlight, which again, we want to harness through proper design, create thermal mass, and actually make a nice, efficient house.
And it's also important to the light, the quality of light inside the house. So we're not affecting that by putting a grey or a green tint on it.
It's a little bit long. Okay. Insulation. Insulation is really important. So, you know, it's the kind of bang for your dollar as well. We know there's different types of insulation and, you know, for different uses as well. So being aware of what's out there and what works best. Most people, you know, will still, you know, we still seem to have moved back to bulk insulation. There's still reflective insulation out there, and I see a little bit of it, but we're tending to use bulk wherever we can now as well. So, and of course, there's composite insulation, which is a combination of those. The R value is the ability of the insulation to trap the heat or the cold on one side or the other as well. So just being aware that, you know, we're maximising that insulation value there, the R value. Reflective insulation, things like the fall sheets, concertina bats, multi-cell bats, those sorts of things that have been in the product, in the system for a while. It reduces radiant heat flow, so allows you to reduce heat gain without unduly restricting heat loss. And so that means it works really well in perhaps in hot environments where it keeps the heat from the sun out during the day, but doesn't trap that heat inside the building overnight. So it allows it to cool in the more tropical environments. So again, if you're working in those areas, you'd be looking for that sort of product as well. It needs a still air gap of at least 25 mil next to a reflective surface to stop the conductive and convective heat transfer. So to stop, you know, the heat from one side contacting the heat from the other side and travelling through that surface. That still air layer works pretty well, but it needs to be constructed carefully to make sure that it actually is a still air layer. There's no holes in it, there's no gaps in it, and you know, wind and what have you can't blow through it. Bulk insulation, you know, we know, you know, been around for years. Basically, the air cells in the bats trap the air layer, trap a still air layer in there, and stops the heat from one side touching the heat from the other side. So the idea there is that it's important that we don't push or constrict those bats at all. So we should be cutting the fit correctly, not squeezing them into gaps, because then they're not working the way they're supposed to be working. And that's really important. There is an insulation installation Australian standard, so try saying that fast 10 times. But just to remember that as well, that, you know, insulation and bulk insulation should be installed without gaps or compressed, as I've said. You know, just by, you know, leaving, you know, 5% gap can reduce the effectiveness of that insulation by about 40%. So all those small little gaps add up. So just being aware of that, you know, and that's important too, where other trades are involved, you know, and we can sort of talk about other trades going in and doing their job, pulling the insulation out of the way and not putting it back, you know, really important. That insulation is put back after the job, that it's fitted correctly around fixtures according to the requirements of those fixtures as well, and that's important as well. And we can see through walls now, you know, we've got infrared cameras, and we can see the differences. What that's measuring is the difference in temperature of the wall. So the picture on the left there shows that there's no insulation in the corner of that wall, because that, you know, that darkness indicates a different temperature to the rest of the wall. You can see the difference in the glass there as well, you know, that it's a lot warmer. So that's really important there that, you know, we now can see through walls. You know, we've done some tests for these as well. The bottom picture on the bottom shows that there's, you know, even the rafters there, you can see that the cold's coming through those uninsulated areas as well. So it's really important. I mean, I've got a little video that kind of summarises the importance of trades here. So it's an important message during the construction process to make sure the little things are done correctly.
Installing insulation is the most cost-effective energy efficiency measure for homeowners to reduce their bills and discomfort from temperature extremes. Correctly installed, it will last the life of the house and require no further cost or maintenance. The Australian Government has also made energy efficient building compliance a higher priority for builders. For you as a tradesperson, it means that energy efficient testing techniques like thermal imaging and blower door testing are likely to become a normal part of building practices. This means the trades need to understand how their actions can damage the energy efficiency requirements on their jobs. As a tradesperson, if your work negatively impacts the thermal integrity of a building, it could mean a lot of unplanned and unpaid rework that could devastate your bottom line. This video resource has been produced to help inform as well as remind trades on how to make sure simple oversights don't negatively impact their business and the quality of their end product. Missing insulation and a few holes or gaps will drastically compromise the performance of the building envelope. A 10% gap could equal as much as a 50% drop in energy efficiency. With a lot of workers coming and going during a build, trades can easily alter building envelope integrity while carrying out their part of the job without even realising it. So let's take a look at what we need to keep in mind when working on a site to prevent this from happening. Often thermal and or sound insulation is installed before other trades are finished. This can be difficult to work around. So trades may move or take out insulation to improve access to do their work. Common examples of this are when lighting or wiring is installed after insulation has been installed, when wall insulation bats are pulled out, pushed back or moved to get cabling, water, gas or telecom lines installed, or when bats are pushed out of the floor joists because insulation has been installed before the flooring has been laid. So it's important to keep in mind that all insulation must be reinstated when work is finished, making sure it's a snug fit. Refer to manufacturer's safety clearance requirements for installing downlights, transformers, fans and hot flues. Trades often need to cut holes in insulation or wall wraps to complete their assigned work. Common examples of this are when holes are cut in ceilings, walls or floors to install plumbing lines, ducts, vents, cabling or telecom lines, or when brick ties or services need to penetrate the wall wrap. So it's important to make sure, where possible, insulation is slit and service lines are chased in rather than large holes cut. Seal all wall, floor and ceiling penetrations with an expanding foam or sealant. Where holes or tears are made in the wall wrap, recreate a weather-tight seal by using UV stable, non-shrink tape to seal the holes. The app also lists safety recommendations when refitting or cutting bats. By reminding each other of these important points that maintain the integrity of the building envelope, we can make sure that unpaid rework is kept to a minimum, properties are built to meet compliance, and property owners are assured of their building's energy efficiency.
Okay. So yeah, just a reminder and some tips there about making sure that it's those little things, and it's not like I said, it's not the idea of the thermography is not that someone's watching you and making sure you're doing the right thing, but it's to make sure, I think, that everyone's is kind of doing what they're supposed to be doing and that sort of things. Okay. So yeah, we've had a few questions about building wrap. We spoke a little bit about that before. So it needs to be in, vapor permeable membrane for climate zone 6, 7, and 8. What's the vapor permeable membrane? It's shown in that Australian standard there, 4,200 as well. And it needs to be installed correctly. And there's an Australian standard for the installation of that building wrap as well. So, just referring to those there. And like I said, the notes will come out to you, and that information will be in the notes, so you can, you chase this up and follow this up yourself. Just making sure that, it's installed correctly. I've got it. There's a short video here with Devon Grant from Grant and Constructions, that we spoke to a little bit about, in terms of what he was doing on his building site, and some tips and tricks. Excuse me. Some tips and tricks about what, how he does it in that. So let's get Devon going. Hopefully he'll buffer all right.
We're here today with Devon Grant from Grant and Constructions, who's building a house down here on the Mornington Peninsula. And I've just got him here. We're going to talk a little bit about insulation and what that means in the construction that he's doing, and what the important things are about installing insulation. So, Devon, welcome today. Thanks very much for making yourself available. Good. Now, when you're building a house and you're putting in insulation, what are you sort of looking at doing?
It's really consistency. It's not having little holes or anything like that. It's sort of like I would say you got to do a visual check, but also a secondary check, just to poke your head, pull a few sections out, because insulation, if it's compressed, it doesn't work as it's performed. Yep. And secondly, I guess I see it as a doona on your bed or a Kathmandu jacket. If there's holes out of it, it's basically letting air in and out. It doesn't actually, and letting the cold and hot in and out. It doesn't hold the temperature properly for you.
So in the construction of the house, when you've got to that stage of installing insulation, like you said, you want to make sure it's not compressed and it's a full layer. So I guess there are some tricky corners in that. How do you deal with those sorts of things?
Yeah, so sometimes before when we're putting walls up, we'll make sure we expand a foam, say, behind wall junctions, because they're areas that often get missed. Or around windows, we make sure we put the expanding foam, but use low expansion foam, so it doesn't bow windows and put pressure on things, and also it stays soft, so it doesn't crack, and it doesn't, if the structure moves, the windows don't get compromised or anything like that. So it has to be a soft type of
so it's that importance of getting it in correctly, so making sure it's not compressed, and making sure that sort of layer is continuous, if you like.
Everywhere.
What's the role of building wrap in the construction?
So I guess like the changes are, it has to be having a condensation management, so having a vapor permeable membrane. So we use the ProClima wrap because it works as a Gore-Tex jacket, similar to what I was saying, the Kathmandu jacket. It lets the moisture and condensation out of your body or out of the building that generates inside.
The sweat,
it lets it out, but it doesn't let the warmth out, because it's not letting the air movement happen in and out of the structure. So for me, it's wrapping it really well to make sure that you're keeping that nice warmth in by stopping air movement, because that introduces the cold temperature. But then secondly, it's almost it's called a weatherproof wrap. So it's a secondary water barrier for me as a builder to protect my structure and to protect from water leaks. So fully taping all the joints, taping to windows, it means that you can flush everything a secondary time. So if there is a crack in render, which happens over a year or something like that, or a brick joint or something like that, you've got a secondary weatherproof layer that's done properly. So it's not just like we have to do wrap because it's part of the requirement of the code or something like that. Yes, it is, but it's also a secondary layer. It's an insurance policy behind your cladding that you've put on.
And again, that making sure it's properly taped. With tape that'll last.
Tape that'll last. So that's a major thing. So it sticks properly, adheres properly, and it's not put on when it's wet or oily or something like that. But it just gets slapped on, because end of the day, as a builder, you're liable for it. So might as well make sure that that layer's done right. It's a small component of the build, but it's where I think major issues with VCAT and complaints happen. Water is a huge issue. So if we can keep it out by doing a wrap properly, then why not take the extra 1 day of labour just to get it done properly?
And as you said, important around windows, obviously, because moisture's hitting them, rain's hitting those windows and then running off. So if we don't get that right, that's a possible spot where that moisture can get in, that water can get in.
Or flashing it properly. Sealing it all up. That's also where major drafts happen. We're using more highly effective windows, better seals and everything like that.
That's a good point.
That's a good thing, but We just need to make sure it's sealed properly around them, because it's just like a capillary action. It just wants to get in, the water does.
So yeah, we're investing in better windows. We're spending a bit more money on those good quality windows, and yet we've got to make sure that the whole system's working properly, if you like.
Yeah, that's right.
Yeah. So Devon, we spoke a little bit about the importance of insulation before, and now can you tell us the role of windows in all that as well?
Yeah, so you can see I've just started to cut back some of the foam fill that we've put in between the window and the stud, just to get continuous insulation all the way around. All those nooks and crannies make a huge difference.
We're keeping the drafts out.
Yep, it's basically air sealing it to a degree and insulating that space. You can see where it's overfilled up at the top, and then down the side I've just started cutting it back so that we can return our plaster into it. I guess secondly, we've got our windows, which we will often recommend people to use awning windows, because they actually get a much better air seal than a sliding window.
Yep.
So that's one particular thing.
So the importance of the seals on the window is really important. So making sure that when you install the window that they're actually all there and they're working properly.
And that the seals are there. Sometimes they're delivered and the seals aren't even there, or because they've come out during transport or that sort of thing. So making sure they're sealed properly, they're nice and square so that the seals are compressing properly. These are thermally broken aluminium. It's becoming more and more common. And these are double glazed with a 16mm spacer, so they're very high performing window, but they're not to a extreme level, but really good performing window for the
and the thermally broken aluminium keeps the heat and the cold from travelling through the aluminium.
So aluminium is basically the best conductor of energy. So it's basically like you could touch that on a cold day and it would be 10 degrees and be 10 degrees outside. Whereas like this, with the thermal break in the middle of the aluminium, you're going to have the indoor temperature on the aluminium here, and your outdoor temperature is not going to travel through. So it's almost like a radiator of hot or cold. Whatever the temperature is inside versus outside, that whole aluminium frame could be freezing cold if it's cold outside, but because it's broken, you're not getting that temperature inside. Or vice versa, it could be at 40 degrees outside and your black windows, they're going to be 60 degrees, rather than having that as a hot radiator on the inside of the house. It's broken, so you've got there's a lot better temperature difference.
So Devon, we were talking before about the importance of building wrap.
Yep.
So can you tell us what you've done here to make sure it's working properly?
Yeah, I guess we're using a vapour permeable membrane. So we chose to use the ProClimber wrap on this. So it's basically wrapped from bottom up. So you always have your laps over the sheet below, just so there's a 150 lap. Moisture can always get out, even if the tape let go, which it's not going to. The tape's pressure sensitive. It's guaranteed up to 110 degrees. So it's never going to get that hot, never going to let go. But moisture, we've got battens going on here with timber cladding going over the top. So if any moisture does get through that or build up in the structure behind it, it's going to have a drainage cavity that can come out all the way down and get out through the flashing at the bottom. So there's no moisture build up behind. The cladding's not directly on it. That's going to build up water, and the timber cladding's going to bow or cup or anything like that. So it's always going to stay in that dry condition, which is great.
And the tape you've used doesn't look like your ordinary packaging tape?
No, so the tape's got a 100-year warranty, just the ProClimber tape, so it's using the full system to its, I guess, full performance. So obviously taped all of the joins so it's fully tight and sealed, and then we've taped it in all the corners so it's like a flashing tape as well. And that's our water barrier at the same time on all those corners. Then just behind that, that's where we've got all our insulation, that foamer so we're fully sealed through these internal corners.
So we've sealed for air tightness, we're keeping the water out as well there.
Yep, that's right. So it's that second...
Right up to the window frame.
Right up to the window frame. There's no gaps, there's no holes. When our plumbers come through and rough in, we put a bit of tape around that, or we put a bit of Orcon glue or a bit of polyurethane just to seal those gaps up so that there's no issue of penetrations with water getting back inside. It's a secondary layer of insurance as a builder. It's minimising risk and exposure of water ingress into the building.
Okay, so yeah, so a nice little chat with Devon there. Devon's doing some really nice quality buildings. He's building quite a few passive houses actually, so he's well aware of those sorts of issues in there. So just to move on, I'm just conscious of the time, so we've got a few minutes, so I'll just move through. So buildings interact with their environment. When the wind blows over and around the house, it creates different pressure points around the house, like it does, for example, on that aeroplane wing there. It moves faster across the top of the wing due to the wing design, and that creates a negative pressure and it creates lift, and that's how those big planes fly through the air. The opposite thing with the racing car there. You know, the idea is that we channel the air around the car and over the car in such a way that it creates downforce to suck that car down onto the ground. Same thing happens on your house. So it's blowing on the house, creates a lift over the roof. So we tie down the roofs, especially if we're in, you know, high wind areas. That's really important. But what it's doing is putting a pressure on one side. So it's blowing air on one side and blowing into the house, which creates a negative air on the other side, and it's sucking it out. And that's how we're getting those kind of drafts through the house there. So yeah, you know, so in terms of the expectation, the NatHERS model expects that the exhaust fans will be sealed, so they'll have dampers on them, that the downlights will be sealed, and there'll be seals on windows and doors. So, you know, that's important that they actually are in place, because your energy rating is assuming that these are done correctly. And again, it assumes, you know, like the question before, it's assuming an air change rate of about 10 cubic metres per hour. So how do we compare? As you can see there, most other countries are about 5 air changes per hour, which is similar, not quite, so someone, you know, will have a go at me, but it's kind of similar to the cubic metre per hour air changes there as well. Most of them around 5. A couple of years ago, CSIRO did a study on 130 houses where they measured the air changes, and they found their results ranged from about 39 air changes per hour, you know, to about between 5 and 10 there as well. So a big range in air changes per hour. You know, 39 air changes per hour, you might as well have the front and back door open all year round pretty much, because that wind is just blowing straight in and out of that house. I'm not sure if you'd even be able to heat it fast enough or cool it fast enough. They found the average was about 15. Like I said, there were several over 30, and about a third of them was less than 10. So about a third of them were actually, you know, complying with the new regulations, if you like, there. You know, it can be an important idea to get this done every once in a while on one of your houses, just to see where you're at in that sort of sense. Because you probably find, I think, you know, most people are now finding they can get down, you know, around 5, 6, you know, fairly easily, you know, just with a little bit of attention to detail. Okay, so yeah, so like I said, most other countries are about 5 air changes per hour. So, you know, that's important as well. Keep moving. You know, we can go around, we can stick that blower door on the house and we can see what's going on. This is a house we did a couple of months ago. I sat in on a blower door test. These are the sorts of things we can find there. So, John there's got an air efficiency matrix. It's got a little smoke machine. So here's been sucked out of the house, and you can see the. I think it's a poltergeist shield through from behind the oven there. Yeah. Cavity sliding door here, internal cavity sliding door. So again, you know, quite a bit of wind coming through that. So quite drafty. I might just quickly say that. No, never mind. So yeah, you know, so something's going on behind that, behind the wall oven there, behind that kitchen. It was quite drafty, and also something going on through the cavity slider there. So making sure they're installed correctly, so that, you know, they're not drafting as well, points of entry for air to come in or air to go out as well. So look, just to conclude, check what happens on site matches your paperwork again. You know, making sure that the products are specified and installed correctly. That any changes are noted on the plans in the contract. Again, you've discussed them with the owner, and the building surveyor is notified and discussed with the discussed with the building surveyor, excuse me, and that the impact on the star rating is checked if required. You know, that's all important. There's a bunch of resources there. Like I said, we'll send you out the notes. These are all in the notes as well. The interview with Devon and Pat McLeod. We've got a couple of videos together, you know, that we'll put up on our website in the next couple of weeks. So look out for those. We may send you an email just letting you know that those are there as well. Like I said, I think they'll be really good, useful resources. For those of you who are interested, we have their Master Builders Green Living training, which is 2 days. Goes into this stuff in a whole lot more detail as well, and we'll give you a chance. You know, we've had a few questions here tonight, but you know, generally get some really good discussion going around some of those questions there. That sort of thing as well. Just to acknowledge that, you know, this webinar was presented with the help of funding by the Victorian State Government, Department of Environment. So we're appreciative of that in terms of, you know, educating the construction industry, which is really important. I'd like to thank again Devon, Pat McLeod, Tony's put in quite a bit of work in this as well. We will have time. It's 5:30, but I'm happy to, we can have a look at those Q&As again for any of the most recent questions. And there will be a survey at the end of this too. So if you could just spend a couple of minutes, I think it's about 4 or 5 questions there, would be great. Oh yeah, here we go. Victoria's put it up already. So if you can just spend a few minutes going through that survey, we'll have a look at the Q&A as well. And like I said, we'll send you some information out. We'll send you the notes out and the information out in the next few days. Infrared cameras, are they expensive? Yeah, look, you know, you can get attachments for your phones now, which work okay for a couple of $100. They're still, you know, not cheap, I guess. A decent camera is probably about $2,000 out there as well. So yeah, you know, like you said there, Oksana, it would be a nice thing that you could hand over to your client as a quality assurance tool as well. So you could go, here you go, look, we've checked the walls and they're looking pretty good. So that's what is really, you know, it is a useful tool, but yeah, not cheap. And you know, you needs a little bit of knowledge to do it properly, but you can get an attachment for your phone for not a huge amount of money. Ian, good day, Ian. Insulation was my biggest battle on site. Yeah, absolutely. No comprehension of how important it is. Yeah, and you know, I used to, a few years ago when I was starting to get right into this role, I spent quite a bit of time with, I've forgotten his name now, which is really terrible. He was a bit of a mentor, really lovely guy, worked in insulation industry for years. Blair, you know, Blair had worked in insulation for years. And he used to say it was like the 5-minute care factor, you know, get that stuff in, get it installed correctly. It really doesn't take a huge amount of time to get it done as well. Christy's a scorecard assessor. Existing houses, yeah, good. Thanks, Christy, for that information there. But the assessment can be done off the plans too. Basically, the house is measured, any gaps are identified, the heating and cooling systems, hot water systems, shower rows, all those sorts of things. Yeah, so it's a true whole of house rating, and it does give you a really good indication of, you know, where you might want to focus your efforts. So depending on the house you've got, you know, yeah, you might say, okay, look, the easiest thing to do is to stick some solar on the roof, but you might want to have a look at the seals and what have you on your doors and windows. That's things that you don't have first, you know, those sorts of things are there. So yeah, look, I think it'll be a useful tool going into the future. Studs and structure from Paul. Excellent for thermal transfer when we move to dual wall systems which insulate between internal and external systems. Yeah. Good question, Paul, and you're absolutely right. You know, I think, you know, we're continuously battling that benefit versus cost thing, a ratio, which is really important, and you're absolutely right. In passive house, they actually measure the conduction of the wall, of the timber in the walls. So they consider a frame, if you've got a timber frame that you don't have any insulation on the outside of it, they consider that as a weakness in that wall structure. So yeah, that's quite interesting. Green Living Conference, I'm hoping so, Gareth, that it may have to be as a webinar. So, you know, it won't be as nice as catching up with everyone on the day. And, you know, it does make it a bit difficult to ask questions, but at the moment, we're hoping to be, we've pushed it back out to September sometime. The way things are going, we may be able to meet, but it may also be in the format as a webinar. So we'll see how that goes in terms of getting people to sit in front of the screen for half a day or something like that. But I hope it will be. So keep an eye out for that as well in the future. So look, that's all the questions there. I'm going to thank you. Just please, yeah, Claire, if you can complete that polling, that'd be great. And like I said, we'll send you that information out. If you need a certificate for CPD, any of you, just send me an email. And sorry, I think the last screen on there was an email. Was my email address, but palviano@mbav.com.au is my email address. So yes, you know, certainly do that, and I'll try and send that out as fast as I can, or send it to the people you need it to go to as well. So thanks very much for enrolling. I hope you found it useful. I'm still getting used to this format as well. It's nice to be able to see people's faces and ask questions in person. But we're hoping that these sorts of things are giving you some useful information. Like I said, keep an eye out for those extra resources in the next couple of weeks as well, because I'm pretty happy with how those have turned out as well. So thanks very much for attending. I will do that. Sorry, I'll put my email in the chat. There we go. There we go. Thank you for that. Other than that, if there's no further questions, I'm going to sort of end it there. Thanks very much for your comments. I appreciate that. Thank you. Like I said, it's a bit hard to see without seeing faces. You can't tell if people are nodding off or getting bored. Thanks very much for that. And if you're interested, keep an eye out for our Green Living Conference, or drop me a note and I'll put you on our mailing, on our email list, and we'll make sure that we let you know about it as well. So all good.